had this digital multimeter for some time now. You can pick them up on eBay for just a few pounds, £2 or £3, something like that. And I don't have any great expectations of the thing. It was just something to use as a backup. So let's have a look at it. As it hasn't been out of the box for years. And there it is. And it's got a bit of an identity crisis because look, it doesn't say the same on there as it does on there. And what's more, when you turn it over, it comes in yellow as well. And even that one doesn't look the same. Now also in the box we've got some cables. There you go. And some destructions, which you just throw those away, we'd never use those again. And some very nasty, cheap and nasty looking test leads. That cable is really, really thin. And there's a thing on there that says 1000 volts. Well, I wouldn't like to touch that cable with 1000 volts going through it, I must admit. And these banana plugs are, come on, focus. They're completely incompatible with all the other test meters. There you go. They do fit. So turn it on. Nothing. There's no battery in it. The one thing you do notice, it is absolutely light as a feather. There's no weight to it at all. I've had other test meters in the past that are heavier than that. Of this sort of construction. Let's get a screwdriver and put a battery in it. Some little screws there. Come out. And there. And it pops open. Click. There you go. And what strange battery connectors. They are really strange. Anyway, we'll put a battery in it. Now it's probably not obvious, but there's a little plus there and a little minus there, so I presume that's the way around the battery goes. But I mean, can you ever remember which way round those go? And that is the plus, and that's the minus. Whether it's got reverse voltage protection, I don't know. Let's try and put that on there. They actually work surprisingly well, actually, those battery connectors. And we'll put the lid on. There you go. And well, I won't bother with the screws for now because it clips together quite well. So you've got voltage up to 1000. And then it comes on, yes, down to 200 millivolts. And you've got an ohms range which doesn't go particularly high, that's only megohms max. And ooh, there's a nice thing. There's a continuity buzzer. Now, does it actually work? Now I remember, this is what I bought it for. Continuity buzzer, but I'd be very surprised if it actually works, although I did see a piezo device in there. Well, it's very feek and weeble. I don't know whether you can hear that, but it is squeaking at me. It's also got a transistor tester, if the thing will focus on it. Not tried that. and it'll do 10 amps. You've got two different plugs. You plug it into that one for the 0 to 200 milliamps, and into that one for the 10 amps. I don't know why they do that, but anyway, it does seem to work. So I'll just turn it off for now, and we'll test it, see how accurate it is. This peculiar looking contraption is a calibration source, and at the moment it's set to 1.00 volts, and this meter is set on the 2000 millivolt range, 2 volts. So if we turn this on, let's see if it gives you 1 volt. Well, 1001, 1002 millivolts. I'm not unhappy with that. 1.002 volts. That's not too bad, is it? We stick it on the 20 volt range. Hang on. On the 20 volt range it still says 1 volt. So that's not bad. Let's step it up a bit. Now let's go, that was 1 volt. 2, 3, 4. Let's try 5 volts. Turn it on. 5.02. It's a little bit up, but it's not too bad. Does that read the same on? Yeah, on the 200 volt range it's still saying around about 5 volts. Sorry about the lighting, it's rather difficult in here today. So I wonder if the current range is accurate. This thing will output current as well. That's the constant voltage position. If I change it to this socket, it becomes constant current. So we'll change that to there, and we'll change this to current mode and set it for let's say 5 milliamps, and we'll have to, oh yes, we turn this over to the milliamps range, and when we turn that on we should get 5 milliamps. Well, as near as damn it. We'll try it on the 20 milliamp range, and there we are, 5 milliamps. So this thing is remarkably good, considering how cheap it was. And I've seen others of these type of meters in the past that have been way out. In fact, I've got one to show you in another video. So I'm not too dissatisfied with that. Now let's try a lower range. Let's turn that off a minute and step down to 1 milliamp so that we can test the 2000 microamp range. Turn it on. Ooh, now that's funny. That is way out, isn't it? 1.067 milliamps, 1.068. So the 2000 microamp range is reading a bit high. Now what we could do is test the 200 microamp range. Yeah, there are discrepancies at these low currents, but I've connected an Avo miner in line, a very trusty old analog device. As you can see, the digital one is reading 558 milliamps, and the analog one is reading more than 500 milliamps. I can't exactly read that from here because it's not in focus, but I would say the analog and digital are in agreement with each other. and not in agreement with this, so this thing is not working properly at the very low currents. I suspect there's some interference because some of these readings are a little bit variable, but it's certainly, I think, quite a good device. Let's put the analog one there, and let's turn this off. Let's stick that on the 1 milliamp. No, that's the 1 milliamp range. That's on the 1 milliamp range. So let's stick a bit more current in. If I can remember how to operate this thing. 90 milliamps. 1 milliamp. Okay. Let's see if they agree. Right, the analog one says it's slightly more than a milliamp, and the digital one agrees. So if we can go down a bit, 90 milliamp, no, 0.9 milliamps. I'm all over the place today, aren't I? Let's move that out of the way a bit. See if we can get the glare off that right. Turn that on. That says 948 milliamps, 949. And the analog one says, well, 920, 940, about 950 something. So they're not far apart. Yeah, the other thing I forgot to mention, this thing smells like death. After so many years in the packet, it still smells like death. I reckon they must have ground up dissidents to use in the plastic for this thing, because it absolutely smells foul. Even after many years of being actually out of the plastic bag. But there you go. Right, let's turn that off. We'll turn that off. And one more thing I want to mention. When you open it up, there's no screen. Look, see, on some of the meters you've got a spring there which connects to a screen over the back there. So this thing could probably radiate interference, and it can probably pick up interference. So I wouldn't like to use that too close to a transmitter or a source of interference. But it's cheapness, isn't it? That's probably why this is so much lighter than the other models. In conclusion then, I would say this is not about 3 or 4 quid's worth of electronics. It's certainly good enough to use as a standby meter. And it doesn't matter if it gets dropped or whatever, or blown up, because it's cheap enough. And unlike others I've had in the past which didn't work, this one actually does work. Oh, and as a final, there's one other thing I wanted to mention, and that is these connections here. Can you see how that's stood? This is the 10 amp one, and that's the bolts and stuff. Can you see how that is only soldered in that one spot there, instead of being soldered all the way around? It's only dabbed with solder there. The same on that one, and the same on that one. So the construction is cheap, and that could be a failure point. So I think I'm going to resolder those just to make sure. But the rest of it is fine.